For this next example, I want you to notice that again we have all of the x squared, y squared, and z squared terms. These are all present, and they're all in this case equal to positive 1, and exactly 1 is positive. And so last time we had exactly 1 was negative, 2 were positive, 1 was negative, and in that case we got a hyperboloid of 1 sheet. And now when 2 of the terms are negative and 1 is positive, we're going to get a hyperboloid of 2 sheets. And so we'll figure out the graph together, but I want you to realize that you can recognize at least the name, and then once you've seen the picture, you'll recognize the rough picture as well, just from the behavior of these x squared, y squared, and z squared terms. Okay, well let's dive in and do some traces. I think we'll start with we'll slice it horizontally with the z traces. To me, that in this case is going to be the most helpful trace, and I think it'll help you see what's going on as well. So let's copy our equation. So we'll have to rewrite it, and let's drag it down here. Don't you wish you could do that with paper and pen? It's pretty nice. All right, so what I want you to realize is, for example, if I let z be 0, then I get negative x squared minus y squared equals 1, which is the same as x squared plus y squared equals negative 1, and you should have all kinds of little alarms going off in your head. And the reason is that you can't have squareds, the sum of two squares, being negative. It's just not possible. And in fact, that's always going to happen anytime the absolute value of z is less than 1. So absolute value of z less than 1 implies that there's no graph. So we've got to go ahead and assume that our z is at least 1. When z is 1, you just get a point because you get x squared equals y squared, which happens when x and y are 0. So let's do a slice now. Assume absolute value of z. Let's say that it's 2. You know what? Let's just say z equals 2. Then I get what? Minus x squared minus y squared plus 4 equals 1. So x squared plus y squared equals 3. I get a circle. And all of a sudden, we can see that as long as the absolute value of z is bigger than 1, we're going to get circles. The bigger you make z, the bigger the circle gets. And so that's enough to already get a pretty nice sense of what the graph looks like. Let's start with that, and then we'll go ahead and cut it the other way to try to see those traces as well. There we go. All right, so here's my z-axis. Oops, yeah, that's good enough. Okay. So let's do it in red here. So we get, there's a space here where nothing happens. Then there's a point, and then you begin to get larger and larger circles the more you go up. And then the same thing on this side of space where nothing happens, and then larger and larger circles. And so that gives us a sense that the graph should look like this, and that's actually very much what it looks like. What if we cut it the other way? This is the x-axis, y-axis, and z-axis. We've been cutting it horizontally. Let's fix a y now. Let's say you can fix an x. It's going to be the same type graph, but when you fix a y and slice it, right? What happens when you fix a y and slice it up? Well, we're going to get a hyperbola. You can already see it there. But let's do it. So let's just look at y equals 0. So we'll look at the trace y equals 0, going back to the graph, then I get z squared minus x squared equals 1. If I think about this in the xz plane, this is a hyperbola, and it's going to open that way. And so you can see that was exactly what we found. There's that hyperbola opening this way. So let's switch this thing to Mathematica and see what it looks like. All right, so here is Mathematica's version of a hyperboloid of 2 sheets. Pretty cool. A good look at it there. Let's scroll down and just briefly look at the traces. Let me make these a little bit bigger for you. So here we're slicing we're slicing by fixing y, and we trace out these hyperbolas. So you can see the name hyperboloid coming into the game, and then there's two different pieces. So it's a hyperboloid of two sheets. We can scroll on down, and let's make this a little bit bigger. We're fixing x's now, and we are getting essentially the exact same graphs as before, just from a different slice. The different slice, but it produces the same looking trace. And then finally, to me, the most helpful trace is when we trace horizontal. In this case, it isn't always the most helpful, but you can see that there's no traces there between absolute value z less than 1. Nothing's happening, and then you get circles. They get bigger and bigger and bigger the higher you go, or the more negatives it gets. All right, so let's end this here, and we'll do one more example.